Hello and welcome to your next lesson in the electric circuits topic. Today we're looking at resistance again, but we're going to do a skills lesson. Your key learning points for today are: recall the equation V equals IR, apply correct technique for drawing a graph, and analyze a basic practical for measuring current and potential difference in a testing circuit. Before we go on to today's skills, I would like you to have a go at these 5 recap questions. Linking back through this topic, answer the following. 1. What is the symbol for potential difference? 2. What is the unit for charge? 3. What is the equation linking resistance, potential difference and current? 4. What is the equation linking current, time and charge? And 5. What is the unit for resistance? Pause the video now, have a go at these few questions, and when you're ready to get to the answers, press play. Okay, so here are your answers. Get ready to mark them. What is a symbol for potential difference? It is a V. What is the unit for charge? The coulomb, or capital C. What is the equation linking resistance, potential difference and current? It is V equals IR. If you've written R equals V over I, or I equals V over R, that's fine. What is the equation linking current, time and charge? Q equals IT. Likewise, if you've given any other type of rearrangement of that equation, that will also be acceptable. Question 5. What is the unit for resistance? Ohm, or the Greek letter omega. Just a little bit of a reminder, the equation that is most important for today is potential difference is equal to current times resistance, or V equals IR, and those units again, volts, amps and ohms. You'll mostly be concerned with this equation today in the format of R is equal to V over I, but we'll get to that later. Now on to the main focus of today's lesson, which is developing your graph skills. I would like you to complete the following. Part 1 is to complete the results table below using the video. You're about to see a video where I use the testing circuit that I used in the previous video to measure the current and potential difference around a resistor. The resistor in this video is a different one to the previous one. The previous one was 10 ohms if you remember. This one isn't, because that would be too easy. I would like you to watch the video and pause it every time that I get to a new value for current and potential difference. Because you may be pausing the video in different places, your results may differ from mine during this experiment. That's okay. As you're watching the video, bear in mind that the ammeter is giving a value in point something or other. That means it's going to be 0 point something. Bear that in mind when you are taking your readings for current. So starting to take the results then. So this is result number 1. Result number 2. Result number 3. Result number 4. Result number 5. and result number 6. Now that you've completed your table, let's move on to the next part, which is to draw a graph of your results, with the current on the x-axis and the potential difference on the y-axis, by either printing out the graph paper that's supplied with this lesson and plotting it by hand, which is the preferred method, or if you don't have the ability to print off the graph paper, you can use either Excel or Google Sheets to plot your graph. Your graph should look something like this, with potential difference up the y-axis and the current along the x-axis, and I would like you to follow these steps. Start off by drawing and labelling your axis. Once you've done that, you should plot the values, and then afterwards, finally identify any anomalies that might be there and add a trend line. Pause the video now. Have a go at drawing and labelling your axis. When you're ready to move on to see if you've managed to draw and label your axis correctly, press play. So let's take a look to see if you've managed to draw and label your axis correctly. If you've done that correctly, tick it off. If you need to make any corrections, pause the video now, make those corrections. Once you've plotted your values, press play and we'll see if you've got the same values as I have. So let's check those values. Remember that your values may differ from mine if you've paused the video at different points, but this is what mine look like. If yours look approximately similar, then tick it off as being correctly plotted. Pause the video now, make any corrections that you need to, and then move on to identifying any anomalies that may be in your results and adding a trend line. A little bit of a tip that I would recommend for identifying any anomalies is to take a look to see where the trend line would go. If there is clearly one of the crosses that's way out of line with the other ones, then you can identify that as an anomaly. If it's an anomaly, you just simply put a circle around it and ignore it. So let's take a look to see how your trend line went. Here's my trend line. As you can see, I decided that I did have one anomaly, so I identified it, put a circle around it, and subsequently ignored it. My trend line passes between the crosses the best that I could judge by eye. If you've done that correctly, give yourself a tick. If you haven't, pause the video now and correct anything that you got incorrect when you did your original plot. When you're ready to move on, press play. So let's move on to the final few tasks. Number 3, I would like you to describe the graph that you have in front of you. And for task 4, which is your challenge task, I would like you to calculate the resistance of the resistor using the trend line that you've just drawn. Pause the video now, have a go at those 2 final tasks, and when you're ready to find out the answer, press play. So let's take a look at my answers. Number 3 was describe the graph. Any description of any graph in GCSE Physics or GCSE Science should include the axis titles in your answer to make sure that you get the full marks. Never use the word it. The word it is banned. So your answer may look something like this. As the potential difference increased, the current also increased. It may have been that you drew your trend line to go through the origin. It turns out that you would have been correct to do that. This resistor is something called an ohmic resistor. In other words, it's something that follows Ohm's law, where R is equal to V over I. If you don't have any potential difference, you don't have any current at all. So when you have a potential difference of 0, you can guarantee there will be a current of 0. So you may have added something like this. This is an ohmic resistor. And in an ohmic resistor, the potential difference is directly proportional to the current. And here is the sort of trend line that you may have drawn. If you take a look, it goes through the origin and it intersects those crosses. Finally, moving on to question 4, calculate the resistance of the resistor using the trend line. So all you have to do for this one is pick a point on the trend line that's nice and easy to read, and then you read the potential difference of it and the corresponding current. So I think that that's quite nice and easy to read. I can see there that potential difference is 5, and I can see there that my current at that is around about 0.335. Then I can input that into my equation, R equals V over I, and it gives me this answer. So 5 divided by 0.335 gives me around about 14.9 ohms. It turns out our resistor was a 15 ohm resistor, so that's pretty good, and we should be fairly chuffed with our answer. Thank you very much for watching. I hope you learned something new. See you again next time.